We've previously seen how to do stoichiometry problems and how to use the concept of molarity. So right now we're just going to combine those two things. We're going to use molarity to perform stoichiometry problems. So let's say we have some simple reaction. We can relate any two compounds, we'll call them compound 1 and compound 2, in the chemical reaction because we know we can convert between molecules to moles to grams for compound 1, and we can also convert between molecules, moles, and grams for compound 2. We saw previously that we can build a bridge between the moles by using the mole-to-mole ratio that comes out of the balanced chemical equation. So we should be able to start at any place on this and then end up in any other place. We could start with grams of compound 1 and get to molecules of compound 2, vice versa. So now we've also seen, we learned this new unit, molarity equals moles over liters. So we should be able to relate moles to liters using the concept of molarity. So for each of our compounds, we should be able to branch off one more time, and we can start with liters of a solution and convert that to moles using molarity, and then continue on with a stoichiometry problem. So exactly the same thing we did before, we're just tacking on molarity now. So let's look at an example. So here we have what looks like a complicated problem. It's really not that bad. What volume in liters of a 0.1 molar nitric acid solution? I'm going to go ahead and write this down. So what volume in liters of a 0.1 molar, which would be a 10 molar nitric acid solution, is required to completely react with 35.7 liters of a 0.2 molar sodium carbonate solution, according to the following balanced equation. I like to write my numbers down here just so I keep it organized and I can see where I'm starting and where I'm ending up. Anytime I see a big M, I remember that stands for moles per liter. That's going to make my life a lot easier if I can remember that that's a fraction, not just a number. So let's keep this in mind and go back and look at the map we made. So we have liters of sodium carbonate, we have a couple molarities, and we want liters of nitric acid. So if we go back and look at our map, we're starting with liters of compound 1. We have a molarity, so we can turn that into moles. We have a balanced chemical equation, so we can use the mole-to-mole ratio to get moles of the second compound. And then we have a second molarity, so we can get back to liters. So this should be a 3-step problem. Liters to moles of the other compound, back to liters. So this is just like the stoichiometry problems we were doing before. So let's see if we can work this out. Ooh, yep, we need my equation. There we go. So I have 35.7 liters of my sodium carbonate. So let's start there. I want to get rid of my liters and turn it into moles. That was step 1, and that's what my molarity does. For every 1 liter, I have 0.2 moles of the sodium carbonate. So now my liters cancel. The next step was to use my mole-to-mole ratio. So I want to get rid of the moles of sodium carbonate, and I want to relate it to nitric acid, so I'll put moles of nitric acid on top. And now I just look at the balanced chemical equation. There's a, no coefficient, which means a 1 next to the sodium carbonate, and a 2 next to the nitric acid. So I've gotten rid of those moles. I'm just going to continue down here. So now I want to get rid of my moles of HNO3, and I want to turn that into liters, because my final question mark was liters. And again, that's where I use my molarity, 1 liter for every 0.10 moles. So notice we flipped it, but that's fine. We've been doing that with molar masses, densities, not a problem whatsoever. The moles go on the bottom, which means that 0.10 also goes on the bottom. And now my moles of nitric acid cancel, and I end up with liters of nitric acid. So I do the math on that, and I get 143 liters. That's it. No different from stoichiometry that we've been doing before, except instead of molar masses here, we were using molarity to do the conversion. But overall, very, very similar. You just draw a map, figure out, start here, end here, how many steps do I take, and what conversion factors do I use to get there.